Okay, in this video, this is the last video of the chapter, we're going to go over what are called colligative properties, which are properties that vary based on concentration. Realistically, I'm only going to go over two. They have a very similar equation, so this video will not be terribly long. Right, so again, colligative properties, any property that varies based on the concentration of the solute in our solution is a colligative property. There are a bunch of them. You have osmotic pressure, right? So the ability for things to travel back and forth in a semi-permeable membrane. The ones we're going to work with are boiling point and freezing point. Right? So for the equations, boiling point elevation, if you add more solute in, the boiling point goes up. The equation is right here. So the change in boiling point is equal to a constant that's based on the solvent times the molality of the solution times the number of pieces the solute will break into. For an ionic substance, this is going to be based on its dissolution equation. I have an example for aluminum bromide here. AlBr3 will break into an aluminum ion and 3 bromide ions, so a total of 4 pieces. Molecular solids don't break up into smaller pieces, so they have an I equal to 1. So adding a solute increases the boiling point. It also decreases the freezing point. This is the reason why they add salt onto the roads in winter. When the salt dissolves, it lowers the freezing point of the water low enough so that it will not freeze under those normal conditions. And notice, the equation looks extremely similar. The change in freezing point is equal to a freezing point constant based on the based on the solvent, times the molality, times the number of pieces. So as a quick example, what happens to the freezing point of a 0.15 molar sodium chloride solution? Kb is negative 0.51. Well, the change in boiling point is Kb times m times I. So Kb is negative 0.51. The molality is 0.15. I is equal to 2 because sodium chloride will break into a sodium ion and a chloride ion. I plug in, I get a boiling or a freezing point change of negative 0.153 degrees Celsius. Since the freezing point of water is 0, the freezing point of the solution will be 0 minus 0.153 or negative 0.153 degrees Celsius. So that's it for loose solutions. I know it was a lot. We'll be working on a bunch of problems in class, and I will see you then.